So Kafka Connect. Considering Jorge went through many slides in half an hour, gives me confidence that I can do the same. Thank you so much. So Kafka Connect, bridging your data. A little bit about Wolt, because, I have to tell stuff. You might know us from having delicious food delivered to your door, not only food, by the way. So a little bit more about this on this slide. Statistics, we are in 27 countries, 500 plus cities, and not too shabby reviews on App Store and Google Play. So yeah. More. Here's Daniel Pereira de Freitas, first of his name, my best bud and dear colleague, unfortunately is sick because, he was supposed to deliver this talk, but I'm his failover node. But I felt like I have to tell that this guy made majority of the slides I'm about to show, except for the end part because I had to add something. And yeah, so Daniel, 3 years in Wolt and counting, and we like this guy, he's great. Next up, me, Tati for short, self-proclaimed queen of DevOps, 6 years at Wolt. In normal human years, you can say it's 60. I have to retire soon, but can't afford it. Complex adaptive systems, I love them. That's why I'm still here. And living in the village, but came all the way from the village here just to talk. Agenda. What is Kafka? Because, after last meetup, we realized some people afterwards came over and, hey, what is Kafka? We've been talking for 2 hours. I have to mention. It's useful. Anytime. Kafka Connect, main concepts and deployment methods, and Kafka Connect management. Connected Wolt, the juicy stuff at the end. About lessons learned, because, you have to know. Nobody leaves this room until you know. Q&A. So, let's go. About Kafka, a couple of words, what it is. It is actually a distributed streaming platform, high I/O, fault-tolerant, scalable, publish, subscribe messaging system. So you can publish, you can subscribe. Some people say it's distributed, append-only commit log, which is also not a lie. So, Kafka at Wolt right now, and probably this slide is already outdated because, when you sleep, the infrastructure is drifting. So people create new stuff. So 25 clusters in production and counting, largest cluster 777 topics. And we were like, please don't add more because we like this number. 15 nodes and then about 23K partitions there, 170 clients, consumers and producers, and about 28 connectors. But, may have changed since yesterday. And by the way, we use Ivan. We don't self-host because, I like to sleep. That's why we use Ivan. Yanni, thank you for your service. Yanni in the corner from Ivan. Talk to him. Thank you for your service, man. So how it typically looks like if you're new to Kafka. So it's in between. There are some services that write to it and some services that read from it. Pretty much, roughly speaking. And so premise about Kafka Connect, I would say that marketing material usually says this. Kafka in between, there are some data sources like MongoDB, Postgres, Elasticsearch, whatever you want to get data from, and then some targets. So some connectors here that run, and then they, put data in some targets. So it's essentially a way to move data from A to B, where you don't need to write all the code yourself. And reality is kind of a tad more complex. You know how it goes. There are, in fact, multiple processes per each kind of entity which you stream. Things can get complex. Things can get out of hand a little bit. And, the Kafka admins may look like this. So this is me sometimes, yeah. And probably Daniel on his worst days. So maybe that's why he's not here today. Anyways, enter Kafka Connect. Buckle up, people. What is Kafka Connect? Data integration framework, so streaming data between Kafka and other systems. And it simplifies connecting Kafka to other storage systems, so you can start easily. What Kafka Connect use cases are actually mirroring, Kafka cluster mirroring. Mirror Maker under the hood uses the Kafka Connect framework. Mirror Maker is a thing that, if you need to sync data between several Kafka clusters. So we use it actually for migrations because, the shared cluster, which we end up with, it gets too fat and you need to do something about it. So using Mirror Maker to migrate things from A to B, Kafka Connect under the hood. CDC, change data capture. And here I mean CDC not only for analytical use cases, because mainly when people hear CDC, they think analytics. Not only, there's also operational use case. So sometimes a developer needs to hook up to a change stream from a database. I want to listen to changes from this table or collection and do something else, some other logic downstream. So CDC, building data lakes is kind of related to CDC, honestly, if you think about analytics. Aggregating logs. The very first use case, I remember my nights in 2017 streaming logs through Kafka. It was a connector. It was tough. 2017 was tough. Kafka Connect, scalable, robust, plug and play, mostly plug and play. It's easy to start, but of course, if there is no free lunch, you still have to think. So, terminology, some things to know about if you're totally new to it, and it can be kind of, useful later if you start playing around with it. There is a notion of connect, and connect is actual, API for running your connectors. It's a runtime for running connectors. There is an instance of a connector, so the code that implements a certain API, the process that runs in your runtime. And there is a notion of plugin, connector plugin. So it's a packaged jar file. Like there is a plugin for MongoDB, Postgres, and so on. So they usually reside on the file system where you run your connect. And there is a notion of task. The teeny tiny, most important bit of the whole thing is the thing that moves data around. So the task or tasks, pretty much it's a workhorse that dumps data from and to Kafka. Then we have this thing. So we have source connectors and sink connectors. So source would be here some, database from which you want to get the data. So you want to listen to some events from Postgres or MongoDB, for example. And then Kafka Connect in between, and then target would be the Kafka cluster. So Kafka Connect has some components like connector instance, what I just mentioned, transform. So you can do some transformation if you want to, without writing your own code, and converter. And then pretty much the other side of this picture is from Kafka cluster. It's sink. So you dump data you already have something, but you want to kind of, have a connector to dump data to S3 bucket, for example, anywhere, like Elasticsearch. So same stuff, but on the input and output, live as a function. Everything has an input and an output. So source and sink, so far at Wolt, we have been using mainly source connectors. I don't think we, just had a use case for sink yet, but who knows? Next up, connectors. There is what I just mentioned, connectors. They provide the connection to external systems, handle data exchange, transformers, if you want to do some lightweight transformations on the data in flight. And then also converters for serialization, deserialization. So these are the details. If you dig deeper into it, you're going to learn more about them. And they are kind of also visible in the settings of the connectors. There are distributed and standalone deployments for connectors. And the interesting part is for distributed, it allows multiple Kafka Connect workers to run. So it's not only one process, but multiple. And that's what you want to do in production. The fun fact is you won't believe how many production things ran on standalone. Thinking about we decommissioned one connector lately and it was a standalone. So, not ashamed to admit, but we used it in production for years. It worked beautifully. I should not recommend it to people, but, it happened. And then also it does not guarantee a parallelism, the distributed, because it's multiple processes. But if you cannot, on the source from Postgres, for example, if the logic on Postgres end is such that you cannot do parallel stuff because it's based on replication slots in Postgres, for example, and just one so there is no way to make it parallel really. So you have to really think about where you consume from and what are the capabilities of that system, the source. Then standalone stuff allows only a single Kafka Connect worker to run. Okay, for local testing purposes, but ran it in production, full confession. For development staging environments, great. And then also it doesn't scale. Well, it doesn't scale. I mean, it's one process. What you going to do? So a little bit more about it, how it looks like. Distributed is multiple connect processes, so connect workers, so to say, and then they kind of synchronize stuff. Some certain things they need to coordinate. They coordinate via their service Kafka topics. So you're going to see additional auxiliary Kafka topics when you run connect against your Kafka cluster, and then they're going to be these guys synchronize between each other based on the data in the topics. But the single dude, the single mode, deployment mode is it just has state on a file system. So it's like a file on a file system for one process where it writes stuff to know, okay, if I stopped, where should I resume from? Because, from the source system. It's kind of scary, especially when you have to migrate this guy and you have to copy that file, this precious file, which, it's scary. So don't do it, please. Don't repeat my mistakes. Hashtag no regrets. Had to do it. I had no time. So required configurations, some stuff that Daniel added here. Of course, you have to specify where you want to, write data to or read from. So Bootstrap service, the Kafka broker connection string, group ID. Then also, these things that I mentioned for distributed mode, the offset storage topic, config storage topic, and status storage topic, how the distributed mode guys coordinate between each other. So you set the topic configuration there. And some nice to have things, client ID. And oh boy, client ID is a good thing when you want to debug and understand who the hell does what in the cluster. Because without it, you are like, oh my God, what's going on? So better set it. And config providers. But anyways, there are, believe me, much more config settings there. So when you really start using it, it's easy. But if you're getting serious about it, about using it in production, please read docs. Because, it pays off in the end. Because otherwise you read them later at night. So managing Connect is a REST API, people. Nothing kind of complicated. So Kafka Connect is usually manipulated through a REST API. And guess what? Not secured by default. So you have to think of something. You have to limit access. You have to think of some. It's really kind of scary to, curl post for production connector without authentication from your local machine. My cortisol levels, you won't believe. And then it uses JSON, as you would expect. So it's pretty much a config of Connect is a JSON file. Interesting endpoints, like Daniel added, interesting endpoints. So connectors, you can check config topics. You can do some actions, like I mentioned. You can actually do curl for stop, resume, pause, restart for a connector. So pretty scary when not authenticated. And then also certain things for offsets since version 3.5 and newer to list the offsets for specific connector, which is nice. And there's much more actually. But there's another way to do this. You don't need to curl. There's Ivan. Yanni, thank you. So Kafka Connected Wolt, a couple of words of how we do it. So we use Atlantis. Probably many of you know what it is, but it's like a thing that allows us to actually have Terraform plans as comments in GitHub. So we can read a plan. So a human makes a pull request, reads the plan with their eyes, approves, and then applies from the PR. So we don't need to switch anywhere to any other system. Atlantis is a great thing to manage your resources. So we use Terraform for the state management of connectors. We have a Terraform module, and thank you, Villa, right there. The guy who wrote a Terraform module. Thank you, man. Like, of course, when we started to use Kafka Connect initially, it was urgent as usual. Like, in a B2C company, things are on fire. A dude comes in, I need connector right now, like yesterday. Of course, some connectors were in pure Terraform, and we run them on Ivan. So, but then later on, module came along, and it's very beneficial because module kind of holds sensible defaults. There is a lot of settings. You'd better define sensible defaults as early as you can, so that you don't have this all technical debt accumulated. You need to fix later, which we do, but not much, thanks to Villa. And then also we use HashiCorp Vault for secrets. So like we store because the connector needs credentials to connect to a database. For example, if we speak about source connectors, for us it's mainly Postgres and Mongo, so it needs credentials. Those are static credentials in nature, and we store them in HashiCorp Wolt. But when Terraform plan runs, we there is logic to connect to Wolt, retrieve it once, and then on apply, just apply and put it into the in Ivan. So yeah. Self-hosted, I have to confess, we started with self-hosted because, it was before, for reasons actually, before even Ivan came along, I think, or before you started to offer Connect, or before we were really, really ready to do it, because it's a leap of faith. But anyways, self-hosted, there were some challenges, obviously, like authentication and security and all that. And self-hosted, we still have for analytics, actually. But, probably going to also entertain the idea of moving them. So partially we have self-hosted connectors, but we are moving to Ivan. We battle tested many things. We learned a lot. And now we feel more confident. A separate cluster for Kafka and Connect. This is what we learned. Don't run Connect processes on your brokers. So there is a Kafka cluster, what Jorge was talking about. There's a set of brokers. They do their job. There's a lot going on, as you have seen in the previous conversation. But, there is actually an option to put the Kafka Connect process on the same machines. Don't do it. I mean, do it in development if you don't care what happens. But because they're going to hog memory, they're going to consume resources, and the load distribution on the brokers is going to be skewed because there are noisy neighbors pretty much. So don't do it in prod. Then monitoring, for us, it's logging and metrics. I mean, metrics are in Datadog because there's a nice integration in Ivan to send metrics to Datadog. For logging, we use OpenSearch. So we stream logs to OpenSearch. This guy looks surprised. Yes, we do. There's a log in OpenSearch. Log in after this talk. So source connectors, as I mentioned, we have source connectors, Postgres, Debezium. You may have heard this word. It's like a very popular kind of, ready-made stuff. So if you haven't, please Google. For Postgres, they are also for Mongo. But there's also official Mongo connector. Mongo guys support. Since we are Mongo users, we, have the luxury of asking them stupid questions in support. So this is nice. So we are using the official Mongo connector. Pretty much, this is, how we use source connectors now. I may have missed something, but, things develop pretty quickly. So this is the state as of yesterday. About a little bit about Postgres and Mongo connectors, you probably have some experience with these databases. They're pretty widely used. How it's in Postgres, it's based on, the streaming is based on log sequence number. So there is a replication slot in Postgres created when you deploy a connector. You go to Postgres and you see, okay, replication slot. And then you can see that LSN is changing. So the connector is kind of consuming data and LSN gets updated because, it keeps consuming. But Postgres is so nice that if connector stops or fails, it's going to pile up the write-ahead log and store it indefinitely, until connector can resume and keep going. So please have alerts. Alerts for disk transaction log usage on Postgres side. It's a nice feature in a sense that, hey, you will not miss out on any data. You fix the problem in connector and you're going to go again. But it's kind of scary because you can be out of disk in production for this reason. So I tell people to take this alert seriously. So change streams in Mongo. How it's in Mongo, I'm adding here a link to, there's a good woman from MongoDB explaining everything about how things work in Mongo, change streams. It's literally like the same notion as in Postgres. There is a write-ahead log, but there is oplog in Mongo. So operations are logged in oplog. And change streams is a watch function above oplog. So, and there is a notion of resume token to track the progress of consumption of data. And resume token is pretty much, it's a hex encoded string and it has a timestamp. So yeah, just some dirty details, but please check the video. It's amazing. I love it. And for Mongo, actually, the oplog also gets, committed and rotated. So it's usually measured in amount of hours or some amount of gigabytes, for example. And there is kind of a risk if your connector stops or, fails for some reason. Things are not going to pile up. Things are going to keep going for Mongo. But, you can wake up in the morning and like your connector was failing the whole night. And you're like, oh my God, the op log has rotated. So, you lost some data. It's nice that your Mongo is not out of disk. It's a different design choice, but, it's not nice because you lost some stuff. But there are ways to work around that. Things to remember. The most important part. Juicy stuff. Things to remember. Consider your use case early on. What do you actually need? Because it's really, it's a good question to ask yourself, what the hell am I doing? Like, what do I need? For example, consistency levels. What kind of consistency I need? And like, do I really need a connector? Because connector is really good to start. It's plug and play. It's easy. But then you're like, damn, I need this and that. And it doesn't support it. So what kind of freedom and what kind of responsibility levels you want in life? Think about it early on, because then you're going to need to migrate potentially. And for example, if you need, I don't know, let's say the outbox pattern that we actually implemented before outbox was supported in connectors, when you in the same transaction need to write to, let's say, Postgres and Kafka topic. In this, you have strong consistency requirements. I think they started to support outbox a bit later, but we needed it sooner. So think what actually you need, and then pick your poison. Moving on. Know what the settings mean and which are critical. Start with common defaults as early as you can. So there are very sensible things for error handling and the heartbeat topics and so on, so that your connector lives long and prospers. So please check documentation or write a Terraform module. Vila, thank you again. Then check what you are streaming and the size of the messages. So like what the messages are going to be. And it's very useful to see the topic, the topic size growth trajectory, especially at early stages. Some guys deploy a connector, go for lunch, fall asleep, out of disk, So it's good to keep an eye and actually check the size of messages, and actually look at the message. What the hell am I streaming? Is this what I need? Is this the format of the message that I expect on consumer side, for example? You won't believe, but some people don't do it. It's a shame. So later on, do not deploy connectors on the Kafka brokers, because noisy neighbors, logical, but still happens, Then later on, heartbeat topic settings and error handling settings I mentioned. Alerting, because there are risks associated with connectors failing. Let's say Postgres, it's kind of scary. Even with Mongo, you may want to know sooner than later, because if your op log in Mongo has not rotated yet, you have a chance to, hey, I can, backfill. There is a setting for backfilling there. Also, for Mongo, be mindful of the op log rotation. Like I said, you can fix it. I link some documentation here. We're going to share the slides afterwards. For the backfill, it's like we found the setting startup mode timestamp. So you can actually, when connector was failing for some time, you can define these settings in connector, startup mode timestamp, and then timestamp start at operation time, 2 hours ago. Because, he started to fail 1.5 hours ago. I want to backfill. But the thing is that this works only based on op log. If op log is already gone, it's useless pretty much. But there is another setting, copy existing. So please check it out if you need to backfill. But of course, when you backfill, you have to think about the load on the source as well. So your Mongo is going to be doing more work, for example. So useful stuff. Size of the Kafka message also plays a role, because if there's default Kafka message size, and there's also bigger messages can arrive, for example, from Mongo, because you may have a huge JSON document there, for example. And it's good to think about it maybe in advance a little bit and set the message size, because essentially, a connector is a combination of consumer and producer. So it takes from Mongo, puts into Kafka. So it also has a message size setting. And of course, you have to propagate this message size setting to the topic level and then downstream to the consumer level, because, there are a lot of settings for Kafka message size. Please don't repeat mistakes of, setting the message size on broker level. You can do it, but, reverting this is hell. So just change size on topic level. And then also things we learned, which is interesting. We wanted to entertain the AWS RDS blue-green deployments. We use Postgres in RDS, so mainly Auroras. There's this new cool feature, blue-green. to switch over. This is useful for upgrades of databases, zero downtime. So you can potentially, switch over to newer version and switch back if you need to. And this feature, apparently, as we tested, requires all replication slots on source to be dropped. And as we know, the connectors are literally replication slots in Postgres. So you have to drop stuff. And you're going to lose data for analytics, for example, because this is a very legit analytical use case. Kind of a drama. We reported it. We are waiting, but, not nice. But yeah, test it. So still going the old way to upgrade Postgres. Yeah, things to remember. Kudos to our SaaS provider, Ivan. Yanni, thank you. Yet again, greatly facilitates deploying separate Connect clusters. So we have like a one-to-one relationship, Kafka broker cluster to its own Connect cluster. And then Terraform provider is pretty good. And the automation is, yes, it works. Thank you. Ivan handles a lot of the heavy lifting behind the scenes for you, so it makes our life easier. Key takeaways. Know your configs, people, early on. It pays off. Write a Terraform module if you can, if your adoption of Kafka Connect is going to be wild. Then, also, use Terraform configuration management and SaaS whenever possible. And also monitor your clusters. Monitor your clusters and also, connectors as well, because there is a lot of metrics just for connectors. And use distributed deployment instead of standalone. This is going to be kind of, saving your sleep. We are hiring, unexpected. We are hiring slight people. We are hiring TA ladies, just they're outside waiting for you. And please check our positions. There is this senior Kotlin engineer fintech, but there's many more. So, scan the code, but also talk to people. There is this careers.wolt.com. So, Q&A.